Hi there guys, and welcome to HSC Chemistry, topic number 3, chemical monitoring and management. This is actually the third component of this topic because now we've moved away from our initial look at the different branches of chemistry and the importance of monitoring chemical reactions through into the Haber process as a specific example of a process that needs to be monitored, an equilibrium that if we understand what's going on, will allow us to increase the yields of the product. This third section is looking more at the analysis of different types of products in more of a ionic kind of way, and analysis of the different ions that are present. So part of the importance of analytical chemistry is that it enables us to identify what types of ions are present, both qualitatively, whether or not certain ions are present, and quantitatively, how many there are for different substances. This can include mineral drinks, for example, that contain certain types of mineral ions. It can include things like waterways and identifying the different ions that may be present in some of our waterways as well. So the focus of this particular, I'm going to split the ions up into two videos, one on cations, which will be the next one, and one on anions, which is this one. And the main reason we're doing this is because there are 4 anions that are listed in the syllabus as being critical ones for you to understand and remember. And what we need to do is we need to describe different ways of testing for the presence of each of these ions. So the ions involved are carbonates, chlorides, sulfate, and phosphate. So what we'll do in this particular video is we'll actually focus on the sequence of testing for each of these. Now I should point out at this stage that both in your notes on the Canvas website, in the booklet that you have, and also in several of the texts, you'll find tables and also flowcharts which describe these processes. I've actually taken a couple for this particular video from the Conquering Chemistry, the Nelson book by Roland Smith. But there are multiple ways of doing this, and I'm just going to pick one that's actually different to the one that's in your textbook, in the Jacaranda book, just to give you an idea about the different ways in which these tests can be identified, and for you to try and pick something that you're going to be able to remember and recall when you're actually applying it to unknown solutions. So the important thing about this is that we have both qualitative and quantitative tests that we can carry out, and the difference of those, a qualitative test doesn't have any measurement. It's simply saying, yes, I can see that a gas has been evolved, there are bubbles here, so there must be a gas. Or it's a white precipitate, or there's no precipitate, or it's a green or blue or brown color, and those are qualitative observations. But we can also do quantitative ones, and in fact one of these videos will actually look at a quantitative analysis, a gravimetric analysis based on the sulfate content in a fertilizer. So when we're doing quantitative data, we're looking at, say, the mass of a precipitate, or maybe we're trying to measure the volume of gas produced, and so on. So let's have a look at some of these tests. Here's the table, which gives you a bit of an idea about the different types of ions that are here. So we've got the carbonate ion, the sulfate ion, the phosphate ion, PO4, and the chloride ion. So let's have a little bit of a look at each of these in a bit of detail. Firstly, probably most importantly that we want to look at is the carbonate ion, because of the 3 of these, the carbonate ion is the only one that is going to produce a gas in nitric acid. And that gas is going to be carbon dioxide. It's the only one that produces a gas, and we use nitric acid. One of the things that you'll be starting to notice here is that we use a lot of nitrates. So testing involves mainly group 1 metals plus nitrate. And the reason for this is that group 1 metals are all soluble, so all of the salts of group 1 metals, sodium, potassium, and so on, are soluble, and all nitrates are soluble. So anything nitrate is going to be soluble, and sodium anything, potassium anything is going to be soluble. So you'll often find these are being used as part of our reactants in order to try and see if we can get some sort of precipitate out, because these ones will form spectator ions and won't participate. Now, hydrogen ions are also in this category, and so therefore if we put hydrogen ions and nitrate ions together, we get nitric acid. And when we put nitric acid into a solution that contains chloride ions, phosphate ions, sulfate ions, and carbonate ions, we'll get bubbling, but the only bubbling that we get is a result of the presence of the carbonate ions. Now, one of the things to keep in mind as we're going through this is a lot of the time your tests are going to be elimination tests. How do we eliminate these from a potential solution in terms of being able to identify? So if I just give you something and it looks like water and it has a salt in there, and I want you to identify what the anions are, then these are the tests and these are the sequences that you need to go through in order to identify them. So the first thing you do is you can add nitric acid. If you get bubbling, then you know that carbonate ions are present. If you don't get bubbling, then all you know is that there are no carbonate ions present, but we can't identify the sulfate, the phosphate, or the chloride as a consequence of a negative test. That is, there is no bubbling. So what we can do then for sulfate is we can add barium nitrate. Now, barium nitrate is going, because the nitrate is soluble, it doesn't matter what the cations are, they must already obviously be soluble or they'd be a precipitate as it is. So all we're trying to do now is identify the sulfate. So what happens is that when we add barium ions, the barium ions are going to combine with the sulfate ions, and they're going to produce a precipitate of barium sulfate. That's a solid. So that's what's actually going to happen in this next one. The addition of barium nitrate to an acidified sample of the solution produces a thick white precipitate. And notice it's an acidified solution because we're kind of following a sequence of steps down. We added the nitric acid before, so therefore it's already the presence of hydrogen ions is increased. Partly that is to, I guess, address the fact that carbonates also have a slightly basic pH, so we've neutralized those, but in order to test for our sulfate ions, we want to add some barium nitrate, and that will produce a precipitate of barium sulfate and pull the sulfate out. Now, of course, if we have an excess, then we make sure that we precipitate all of the barium sulfate out, and it doesn't matter how much we add, all we need to do is to weigh that solid, and as long as we've got all of the sulfate ions out of the solution as a precipitate, then we can weigh that precipitate and work out how much sulfate ions, what the concentration of sulfate ions was in the original solution. You'll notice that lead nitrate also works in this case, and it will produce a white precipitate of lead sulfate in the same way that the barium did. The test for phosphates are a little bit more complex in this situation. We add ammonia and then barium nitrate, and that will also produce a white precipitate. If we add magnesium ions in ammonia as well, there is an ammonium nitrate buffer which gets set up, and as a consequence we produce a more complex white precipitate, which is this one here. Now these are more complex ones, and they are more difficult for you to try and, I guess, understand. The phosphate ions is probably the most tricky of the four that you will need to look at, and probably the barium nitrate test will be the simplest one to look at, but we'll actually do this in the laboratory, and because it's a little bit more complex, it's kind of a little bit harder to explain just on a slide here. So I'll just let you read through that information, and we'll come back and do that as a prac in class a little bit later on. The chloride ions are fairly straightforward. The best test for chloride is silver. Silver forms precipitates, which is about everything, but chloride ions are mostly soluble. So most of the compounds of chlorides, or the compounds that involve chlorides, are generally speaking soluble in water, but silver is one of the exceptions, and so we can form silver chloride solid, and that gives us our precipitate of the chloride ions. So effectively, if you can carry out your test for the carbonates and find bubbling, then you'll get your carbonates. If you find no bubbling, then you can carry out your barium test to see if we can acidify in an acidified solution, precipitate out the sulfate ions. Notice that the addition of ammonia is going to try and counter some of what has already been put into the previous solution in order for us to produce a precipitate of barium phosphate. And so that would be a fairly simple, if I just oversimplify it a little bit here, then what we're going to have is effectively a precipitate of barium 3PO42 solid. Okay, and then the chloride precipitating with the silver ions. So these are your 4 basic tests for the presence of these anions. A little flowchart is also something that you'll see. I'm looking at this myself. I've got my glasses on, so I'm assuming that it is actually slightly out of focus. And again, I'll make sure that this is available for you so you can read it very clearly. But this is how we sort of, I guess, try and remember it. If you like tabulating information, you can perhaps use the previous slide. If you prefer a flowchart, and sometimes flowcharts are used as questions and also a useful study tool, then you can work through your sample. So with the sample, the first thing we do is we add our acid, our nitric acid. This becomes an acidic solution. And if bubbles form, then this is the place where the carbonate ions are coming out. If no bubbles form, then we continue. We now have an acid solution. For our acid solution, we add barium ions. If the barium ions produce a precipitate in the acidified solution, then we have sulfate present, and it's barium sulfate that precipitates out. So the positive test here, that the substance that we produce is carbon dioxide gas, and in the second case, it's barium sulfate, solid. Now we have a residue, so that precipitate can be filtered in order to remove the sulfate precipitate, and then we get left with the filtrate that we then try and basically raise the pH. So it's an acidic solution here. The addition of the ammonium ions starts to counter the H+ ions, and so we try and raise the pH. Once we do that, we add additional barium ions, and as a consequence of that, we will be, if we get a positive test, we know that we've pulled out the phosphate ions as a barium phosphate. And that's probably sufficient for you to worry about at this stage. So again, because it's a precipitate, we filter to get our residue, and then we've got a filtrate that remains, and with the remaining filtrate, then again we can acidify. Just makes the reaction a little bit easier, drives it more towards a completion, which now allows us to identify now that there are chloride ions present through the presence of a silver chloride precipitate. So same information as the previous table, but just a slightly different way of presenting things. And this is kind of a useful flowchart for you to work through in order to identify the presence of unknown ions in a solution. So the sort of question that you're likely to get then is something like this. A flow diagram shows a series of tests that can be used to identify carbonate, chloride, and sulfate ions present in a sample. And often the phosphates are left out because they're a little bit more complex. Explain why the analysis must be performed in the sequence given. So we need to explain. There needs to be not just a description of what's happening, but a reason why it's happening, and why this particular analysis must be performed in the correct sequence. So you'll see the first thing we do is we add our acid, and that is going to precipitate bubbles of carbon dioxide if there are carbonate ions present. The next thing we do is it's an acidified solution, so now we add our barium ions. So perhaps in the form of barium nitrate, the nitrate remains as a spectator ion, and this is going to give us a positive result for sulfate ions. And so the compound that we're looking for is barium sulfate as a solid precipitate. If we can filter off the precipitate and keep what is left, then if there are chloride ions present, they won't come out with the barium, but they will come out with the silver. And so the silver is going to produce a precipitate of silver chloride, and that will be the white precipitate that forms in the third situation. Notice that when we analyze information from the marking center, it's telling us that the best responses provide two specific reasons for the test being carried out in the indicated order. Neither of the sulfate or the chlorides will produce bubbling when they react with the nitric acid. But it is possible that if we were to add barium first, that we would precipitate barium carbonate, and therefore we would not necessarily know whether the white precipitate that we were forming was forming barium carbonate or barium sulfate. Likewise, if we used something that was, for example, going to precipitate like silver, if we move the silver further up, now silver will form a precipitate with all three of these ions. Silver carbonate, silver sulfate, and silver chloride are all insoluble. So if we start with the silver, then we're going to end up with just a whole heap of precipitates, and we won't know which is which. So the important thing with the sequence is not just that you can identify each ion, but that you can do a test which will only identify one ion, and that's the trick. Thanks for watching.